Great. Thank you, Andrea. All right.
No
Hello, everyone. Welcome to ONOS TST meeting. This is the first one we've had for quite some time. And this morning, Karthik from Samsung Research Institute is going to do a presentation on AI-assisted automation for ONOS. And so I'm going to, without further ado, just let him take the reins and proceed with the presentation.
Yeah. Thank you, Thomas. Greetings, everyone. Myself, Karthik here. So I have with me my colleagues, Sarita and Senthil. We'll also jointly kind of collaborated on this proposal. So firstly, thanks for taking your time. I really appreciate. So it has been an honor to kind of present some of the stuff which we thought that can be a useful thing in ONOS. So let me start. So this proposal presents a comprehensive review of AI applications for SDN control network. With references to few use cases, we'll see how AI-assisted automation brings better quality of experience to operators. So we have organized our presentation into 4 major parts. So we'll start with an overview of how we can translate the benefits of traffic prediction to optimize operational expenditure and influence operator experience in a better way. We'll also talk about software components which are being planned as part of our development. Further, we'll talk about our strategy to develop these 2 blocks, that is time series prediction and smart automation framework. Sorry. So basically, we will also see that what we have done is, before coming up with this proposal, we have kind of extensively studied ONOS community, and as you know that Samsung has been prolifically contributing to ONOS for past 5 years, and so we thought that there is, I mean, to the best of our knowledge, there is no existing work on traffic prediction. So hence we came up with this proposal. So all development will be targeting in existing ONOS architecture. However, we want to give a leeway for future works in forms of offering AI as a service to evolving micro ONOS architecture. So this also we thought about it. So we will see. So this is a glossary of terms. I'm skipping this. So going on overview. So basically, this slide shows the existing art on the ASIS. So wherein operator has to manually screen device traffic for link utilization, abnormality, etc., and has to do correction if required. All this procedure involves hardship, like operator has to deploy operational personnel throughout the day and even in odd hours. So what we are proposing is, or what we are trying to say is, on the right-hand side, we propose to solve this operator hardship by automating the entire manual screening with the AI-assisted traffic prediction. Further, we propose to extend this traffic prediction to the benefits of business logic for meaningful use cases. The use cases are on the right side, actually. So here you can see use cases like deployment assistance, wherein one can monitor the traffic across the devices to dynamically, maybe you can scale out or scale in network functions. The network functions can be, I mean, you can take in any data center. The network functions can be any functions from telecom to enterprise functions. And also, we can also monitor the traffic of device or network to check for the device or link utilization, and gracefully shut down for power saving benefits. And also, we can do some kind of anomaly detection, basically detection of sudden increase in traffic and deriving a pattern. For instance, if an abnormal pattern exists, even after a few hours or days, operator can choose to block such flows. So basically, we are kind of, we thought that we will kind of give a kind of a customizable framework based on the input from the traffic prediction to for the operator to exploit it. All these core use cases can be integrated with the business logic and customized by the operator. We will see the software components required to realize this concepts very briefly in the subsequent slides. Here, all we need, I mean, when you see the software component at a very broader aspect, we need only two components, I mean, very simplified manner. One is the time series engine. So maybe as discussed in the previous slide, in order to reduce manual intervention, we need a framework which collects device traffic statistics and feed this data in a prediction model. The prediction model further based on the customized input can check for a pattern, and forecast and event for automation framework. The next component is the smart automation framework, which is going to be a crucial part of our proposed design. Here we are enabling operator to write their own business logic in form of workflows and automate the entire cycle as a closed loop automation. So we will see the interface definition and how it fits in the entire ONOS ecosystem in the subsequent slide. So this slide shows how two components, time series engine and smart automation framework, will fit in overall architecture. Basically, let us have a look at the overall design briefly. Firstly, we need to collect the traffic stats from the device. We propose to use SFlow or NetFlow to collect the traffic stats. Further, the driver and provider layer will make this data suitable to be presented for the application layer. In the application layer, you can see analytics manager defining the inputs necessary for building the ML model. And the traffic flow would be saved in data store, and the provider would push the collected data to AI/ML engine periodically and initiate the AI/ML training. So the analytics data store presents with the operator the prediction and actual pattern basically here. So this will be definitely useful for the operator to see what is really happening inside and how the AI/ML has predicted and what is happening in the network. So with respect to forecast and how the associated event in terms of workflow association can take place, he will have a kind of a feeling. So finally, the input data set is fed into AI/ML engine. So using REST or it can be even a gRPC interface. So user application will there is a user. These are the application set of applications as we have seen the use cases. The core use cases can be the application here. So the user application will initiate the AI/ML prediction based on the use case requirement. So in summary, these are for ONOS contribution, we have to develop all modules as discussed. Some of the existing models like workflow engine shall be reused to integrate intent-based business logic. So this is how we thought about how to be fitted in the broader picture of ONOS. Moving to slide 6 actually. So this slide focus on the flow of information from ONOS to the time series engine. So we will start our interface development with REST-based. Basically, we believe it will be simple to start with REST-based. Also, we'll be focusing on developing optimized middleware for data processing. So this data processing unit shall act as a server with each and every use case placing their request as a client. So the model training and time series engine will be deployed using PMDARIMA open source library. So we'll talk in very brief how we are going to integrate this PMDARIMA open source library in subsequent slides. So this is a very broad overview on the development plan in ONOS. So basically, we have divided the entire development in 3 phases. So phase 1 and phase 2, we anticipate that it should happen in parallel. finally, we will enable operator to integrate the business logic through workflow in phase 3. So here you can see that as part of the as part of the first phase, actually, we will kind of bring the PMDARIMA integration in the AI ML model, and actually we will kind of integrate with the existing ONOS architecture. So on the device on southbound interface, you will have a list of devices which will be pumping the statistics in the form of flow protocol. And this will be kind of integrated with the flow collector and further with the message decoder, as we saw in the previous slide, actually, how the how the provider layer can facilitate and send the data to suit the application need. And finally, we will have this from the store, we'll have this AI ML controller and the AI ML API server kind of talking and integrating with the AI ML engine. And we propose to use, as I discussed earlier, we are kind of evaluating, and we saw that PMDARIMA can be one of the open source library which can be used. So from ONOS perspective, actually, what will be the interest is we feel that all these components actually will be kind of interest to kind of integrate with the AI ML engine. So this is at a high level, the plan of what we are going to do in ONOS. And okay, so this is a very high overview of PMDARIMA, actually. So PMDARIMA is an open source library, and it's a Python library, as we know, that is used for time series forecasting. And also we did many experiments. We did with simulation. We have collected few data sets, and we did even evaluating the PMDARIMA, and also found that it has extensive use of creating time series plots. It is easy to use and generate time series forecast on the ARIMA model. So we believe that this integration will be very fruitful. Finally, basically, as we discussed earlier, so we will kind of see how we can integrate, basically. So as part of first step, actually, we will use REST API implementation to push traffic data and basically training request and basically prediction request. So this will be this is a very high level thought. So wherein actually we will kind of show the necessary messages between the ONOS based on Java code and PMDARIMA libraries. So this is a broader view of integration. So next, coming to the flow protocol, actually we believe that there are some vendors, some devices which uses SFlow like HP, and some devices like Cisco which uses NetFlow. So in a whole, we cannot deal only with one SFlow or a NetFlow protocol. So we need to have both of this protocol intact running in ONOS. So as a development strategy, we want to start with NetFlow. Basically, the reason being, actually, it is a simple thing when compared to SFlow, and basically also in SFlow we have the overhead of mirroring. But anyway, based on the sampling rate, we can average it out one out of n packets. That can also be possible, but we believe NetFlow should be the good point to start with. So this is a very high level picture. Maybe we can get to the questions here if there are any. Yeah.
So just to be clear, so you're going to collect then via SFlow and NetFlow through existing kind of provider architecture, but not through the existing set of providers, right? It'll be
Yes.
a completely new set of providers that are designed to be able to basically channel the statistics upwards towards the controller, correct?
Yes. Yes.
And the store itself is not going to be the flow store, but it's going to be its own store that basically collects the flow statistics and for the purpose of the, you know, in a time series manner, correct?
Yes, 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 Thomas.
I think that's yeah. I just wanted to. I mean, that's kind of what I understood, but I wanted to make sure that I understood it correctly. So I wanted to.
Sure. Yeah. Yes.
Any other questions? Okay, if not, I guess you can proceed probably as this section.
Okay. So maybe, I mean, what should be the next step, or how should we go ahead? Maybe if you can advise or direct us, it would be great. Yeah.
Well, so I mean, normally we kind of the advice is to start with clearly. I mean, as you've done with the kind of overall design and purpose and a high level architecture. Probably the next step we always recommend, and that's what we generally try to do ourselves as well, is come up with this basically set of APIs, and that which basically define the kind of crystallize the boundary layers and the language spoken across those boundary layers, the entities and the kind of the nouns and the verbs of the different parts of the system. But clearly there's more than one way to approach this, but that's generally the approach that we tend to use.
Sure. I agree with you. Yes.
Yeah, even like with micro ONOS, we generally start with the gRPC interfaces and then kind of split things out from there.
Okay. Sure. Yeah. Sendil and Sarita, you want to add anything here?
No, sir.
Yeah. Okay. Thanks, Thomas. Thanks for your time. Actually.
Yeah, this is quite interesting. Now, for the in terms of do you plan to do any sort of like labeling for the data, or do you expect that to be just all
okay
for the training of the models? You know what I mean? Or do you expect to do auto labeling?
Yes. So basically, what we are going to do is we will kind of take one use case. Maybe we thought this. I mean, in order to give a kind of a crystal clear picture, we will take one use case. And for example, the use case, if one use case which can be thought is, for example, basically you kind of probe the devices, that is your routers, switches, and find that traffic stats is not so I mean, you probe the traffic stats and you find that there is a lean time basically during early morning, say 2 to 4 or sometime. So this lean time can be used for any kind of maintenance activities or any kind of activities which the operator may find very difficult to kind of deploy the personnel and do it. So what we do is we label this particular time after studying the pattern. And we see that if any of the devices needs some kind of firmware upgrade or some upgrade, actually, then is this the right time to kind of do that upgrade based on any conditions? Basically, we can also think about some conditions like the traffic characteristics of the device. I mean, the device that is taking the traffic, which is a critical traffic or which can be any traffic. So we study the traffic characteristics. We kind of also see that actually if the traffic characteristics really allows us, if there is only a few traffic which is flowing during the lane period, but is it okay to kind of say that decide that whether yes, it is a right time to label that this is the moment we need to go for an upgrade. So these are some of the use cases which we are kind of chalking out, and maybe we will upload or update in the Confluence page and take a community review. So that's what we are thinking, Thomas. Yeah.
I see. Right. Thank you.
Yeah.
So are there any other questions from the NF side?
There is another use case, which I'm sorry, I joined a little bit late. You might have discussed use cases before. Capacity planning of a network on the links thereof is another good use case if you are using statistics to learn from.
Definitely, yes. Definitely, yeah. Thanks for the pointer. Yes, we thought about this. Basically, definitely in one of our major, one of our major deployments, we found that actually the data center power is too much being used, and we thought that we can do something on this front by monitoring the traffic condition, as you rightly pointed out. We can also kind of augment this traffic prediction for suitably planning the capacity of the, in terms of compute resource and basically the like your CPU, RAM, etc. Yeah.
Yeah, especially in today's world with the supply chain problems that there are, it has become very important to maximize the utilization of the existing equipment in the data centers.
Right.
Because
yes,
it's really hard to expand data center capacity.
Yes. Yeah.
A good point. So how long do you expect the project to take? Just a logistical question.
Yeah. Actually, to be honest, we thought that it will be, at least for one use case to be up and kind of running. We thought that it will minimum take 6 to 8 months. Sendil, is that a good number, 6 to 8 months? What do you feel, Sendil?
Yeah, it will take a minimum 6 to 8 months to complete at least that basic framework would be ready. So, and once the framework is ready, then top of that we can develop our own use cases. So for framework with a minimum one flow protocol, it's maybe a net flow or S flow. So then integrating with PMDARIMA. So we will be planning to make some standard APIs between ONOS and PMDARIMA. And then we'll integrate the PMDARIMA with ONOS. Then that, so implementing protocol, flow protocol plus PMDARIMA integration. So then our framework would be ready. So this, this part, it will take 4 to 6 months. So after that, we will develop few basic use cases. So probably it will take 8-month time period.
Got it. The reason I'm asking is just where you are with respect to use of the ONOS Classic versus the micro ONOS. Clearly, the micro ONOS right now is not fully developed on a control and in general on statistics collection realm. For the most part, we've been focused on configuration and SD-RAN. But at some point, we will return back to doing classical SD and control. And so I just was wondering if certain parts of this architecture ought to be done in kind of in compliance with micro ONOS architecture, just using microservices, gRPC, and kind of separate, basically structured in a separate process and integrate only the parts that need to be integrated with ONOS Classic on a southbound. Anyway, just a curiosity, because you did mention in the beginning that you're trying to kind of steer ahead, right, into the realm of micro ONOS.
Yes, that's a good thought, Thomas. Yes, we are also thinking on these lines. So basically, what is that future we need to plan? So we need to think right now itself. So all the design, I mean, we will be having a thumb rule to kind of think for future, as well as we also need to kind of bring some proof of concept in place actually. So we will try to balance both of this, and we'll execute. Yeah. Sendil, you want to say something here? Yeah.
Yeah.
Yeah, I just wanted to make sure that that was something that you considered.
Yes, yes, yeah.
All right. Are there any other questions or?
One question maybe from my side, is this and maybe I missed it, but is this done on online manner, the training, or is it based on a training set and then the algorithm gets just deployed on top of ONOS?
Okay, so it is an offline computing. So the use case, what we thought actually it's a more aligned with offline, but regarding your question on making it, I mean, I would say for example, you have to, in a case where I have taken the lean period detection or forecasting. So what we need is we need to operate on 1 or 3 months, minimum 1 month of data, or basically say for example, if it is going to be a kind of a Christmas Eve, then actually we decide that, I mean, we see that there will be definitely a lean period towards the end of the year and the beginning of the year. So this and also there will be some kind of trend and seasonality here for different seasons over the year. So this will be traffic stats will be collected and kept in a store, and it will be operated in an offline manner for detecting the lean period. This is one case. And just to add upon that, this is the initial thought only for online case. For example, in case of 5G, actually, wherein actually there is a really very tight SLAs, like you need to honor the latency related SLAs. So wherein actually every second or every other second really matters. So in that case, actually, the online execution really complements. But the problem here is it online takes that much infra also, because it needs to be very accurate, and it needs to be very fast. But in case of offline, actually we can tend to wait. So these are some of the challenges which we are thinking, or which we are anticipating now. To answer your question, right now it will be an offline. Yes.
Yeah, I guess I was assuming that it was going to be training offline. And this is especially, I would expect that particular training component would be done probably off platform as well too, right? Or would that be, I mean, it seems like a natural place to start with separating things into a component that's off the ONOS Classic platform.
Yeah. So basically we thought that, I mean, basically we'll have a separate, when the initial thought is the PMDARIMA will be running separately as a kind of a black box to ONOS, and we'll have a kind of this middleware layer which will kind of, I mean, based on the each use case, it will collect, process, and request for store the data. And this all this model training and time series prediction, which is going to be part of this PMDARIMA, will be kind of running in a separate compute altogether. And yeah, that's what I mean, we have decided right now. Yes.
Have you chosen a database?
Okay. a database, we have really kind of, I mean, I would say that maybe we need some more time to really decide on this. Yes. Maybe we can, we'll have to kind of see. Yeah. If you have any suggestions or anything, you can please share here. So it will help us to kind of probe.
None right now, thank you. I am working on something like capacity planning, but I just started working on it. But I will.
Sure. Yeah, that's a right. I mean, question, but it's too early for us. Maybe we need some more time to kind of fix on it. Yeah.
Thanks.
Yeah, welcome.
All right, so I guess if there is no other questions, we can probably close the meeting. Or did you have some more stuff that you would like to discuss?
Yeah, that's all from our side, Thomas. So we are glad that we got a good comments, and definitely there is a plan which we would kind of, as you said, we'll go back and come with the APIs, and maybe we'll have a review again.
That sounds great. Thank you for taking the time to present, and sounds like an interesting project.
Thanks, Thomas. Thank you.
All right. So did anybody else have any other topics for discussion? Just a really quick, I guess, maybe quick segue into kind of the maintenance of the ONOS 3.0. Pierre, I know I'm putting you on a spot, but do you want to give just a little bit of an update with respect to how that's going? Maybe Pierre and Jordan.
Yeah. So currently what we are working on, actually what I was working on is try to make ONOS building with Python tree. As you notice, starting from macOS Monterey, Python 2 is no longer dropped. Is dropped. So basically, most of the building scripts are no longer working. And probably this is one thing that we have to backport up to 3.0. Even if we are working on 2.5, this is one thing that we are currently working on, and is taking priority as regards to the Atomix Java client implementation.
Yeah. That's quite a bit of a complication, unfortunately.
Yeah,
I mean, we still do have an option clearly to build on Linux, right, for official builds, but it's definitely a severe handicap for the developers using the Macintosh.
Yeah, and together with that, unfortunately, we have to upgrade Bazel, and there will be a big bump from 3.7 to at least 5 dot something. Because there is a bug in Bazel for which we cannot specify the Python version. So there is a bug. Basically, even if you try to force Python 3, the Python stuff that are generated by Bazel
It's Python 2, right?
Yeah, exactly. So we have to move at least to Bazel 5, which deprecates a huge number of options that we have used. So there are multiple things that are going on right now. So another thing that is happening is that Bazel 5 breaks some protocols, like all the protocols that are gRPC based. Yeah.
Yeah, that sounds quite daunting. Actually, it's a little bit of a yarn ball that has to be unwound, unfortunately. So I assume the Atomic's work has been suspended for at least for some time.
So yeah, as for that stuff, so I'm still making progress on it. So when I went up to Menlo a couple months ago, me and Pierre met, and we found a bunch of issues. So what we're trying to accomplish is sort of to upgrade Atomics in Classic ONOS, and to the version that we've been using on Micro ONOS. And one of the issues that we found when I was up there in Menlo was that there were some missing features. Like in ONOS, we allow the client to create primitives. In Micro ONOS, they're defined in Helm charts. So I had to change some things to support being able to basically create primitives from the client. And there are also still some missing primitives and missing RPCs and things like that. So I'm still making progress on those things. So hopefully when Pierre is done with fighting with Basil, we can basically pick up where Pierre can take over adding the Java client.
Okay, well that's great. That's actually kind of fortuitous then. gives you some time. Okay.
Yeah.
All right. Well, thank you guys for the brief update. I just wanted to at least have it kind of on record as to where we were with this platform maintenance. I don't have anything else as a topic. So unless somebody else does, I think we can probably give folks at least 20 minutes of their time back.
I was wondering, when are we thinking about revisiting the other topic that we were going to do a few weeks ago soon, which is the P4 runtime?
Yeah, yes. So that's a great question. I was waiting to. That's definitely something that I'm extremely interested in doing, but I want to make sure that this kind of folds with the priorities of our kind of current employer.
Okay. Yeah. That makes sense.
Yeah, I'm assuming that it does, given kind of the home of Tofino and other technologies. I'm assuming that it does, but I want to make sure that we're kind of all on the same page. But I'm extremely interested, kind of returning, pointing our efforts again at the classic SDN control, but this time rather than being foundationally based on OpenFlow, and the primary foundation here would be P4 and P4 runtime specifically, as kind of as the native. And this would allow us to kind of migrate ONOS Classic use cases to Micro ONOS, but without, with the new foundation and with hopefully fewer complications and fewer layers of abstraction. With ONOS Classic, as everybody knows, while it's shown itself to be quite adaptable in terms of be able to accommodate various southbound protocols, it did come at a cost of multiple layers of abstractions, which made things like dealing with multi-table pipelines a little bit, shall we say, less straightforward than it should be. I think P4 being a fairly well-defined language and coupled with the capabilities of the hardware, and P4 runtime being a very modern kind of conveyance protocol for the P4, I think we have a significant opportunity to take advantage of it and simplify the control plane. That's kind of how I'm looking at it, and I'm definitely eager to start on it, but I don't think probably we have enough clarity yet, or at least mutual agreement of where we should start at this point in time. Sorry for the rambling answer, but that's kind of where things are.
That sounds good.
Yeah, I'm hoping within a few weeks we'll be able to convey that publicly. All right. If there's no other questions or topics, I think we can probably conclude today's meeting. And I wanted to thank again Karthik and company for doing a nice presentation on the AI stuff. And we look forward to future updates.
Sure, Thomas. Thank you.
Great. Thank you very much. Bye-bye, everybody.
Bye.
Bye.
Bye all.
Bye all. Cheers.